Well, we've added, we've subtracted, we've multiplied, and now it's time for division. How do we think about division with integers? First of all, let's just have a quick reminder about what division means. I'd like you to pause this video and just get in your brain, what were we talking about? This is several modules ago now. What were the two primary ways? It was two questions that we might ask that would lead us to the division idea. Pause the video, see if you can get that into your brain. Of course, I'll tell you in just a minute. So with division, there was two questions depending on the context. It could be how many groups or how many in each group. So let's just start with 6 divided by 3. You know how this is going to go by now. We're going to start with just positive integers, then we'll move to a positive and a negative. We'll have two negatives eventually, and we're going to really focus on not rushing to the algorithm, but thinking that will allow students to see with manipulatives, to understand, to make sense, so that long-term their fluency will be developed. All right, so 6 divided by 3. I'd like you to think however you like. Jump to that manipulative, virtual manipulative thing too, and build it out. Like, go through the experience. What would it look like, feel like, if you were in a classroom with kids and they had the red and yellow counter chips, hopefully on a table or magnetic on a whiteboard, and they were actually manipulating it to see division in front of their eyes? Well, you go through that process. 6 divided by 3, maybe both ways. How many groups? How many in each group? I'll give you a minute. All right, so 6 divided by 3. Here's how your brain should be thinking about it. 6, shall we say, how many would be in each group if I broke 6 up into 3 groups? So group 1 would have 2, group 2 would have 2, group 3 would have 2, 2, 4, 6. Each group would have 2. There'd be 2 in each group. Or what if I said 6 divided by 3 as in, I'm going to put 3 in each group. How many groups would there be? Well, you can make a group of 3 and a group of 3. You'd have 2 groups of 3 to get 6. Either way, you get 6. But here's how it might look with your manipulatives. You might say, sorry, here we go. How many copies of 3 give 6? Now, I'm going to take us through. Since we just got done with multiplication, I'm going to take us back to this primary way of thinking about multiplication. And since division is just the inverse operation of multiplication, instead of telling us how many copies, like remember 5 times 3, 5 copies of 3, this says how many copies of 3 give 6. And so here's how it could look. Well, there's a copy of 3. Do you have 6 yet? Nope. There's a copy of 3. Do you have 6 yet? Yep. So how many copies of 3 did it take to make 6? And notice I actually started with 0 again. Starting with 0 again, I had to create and think through how many copies. So I created a copy of 3. Do I have 6 yet? Nope. I had to create a second copy of 3. Do I have 6 now? Yep. And so 6 divided by 3 is 2 because it took 2 copies of 3 to make 6. 2 copies of 3 made 6. Now, just for a minute, let me grab my pen. Just to connect back to the other ways, notice that if you thought of it the way I brought it in, there's a copy of 3, and there's a copy of 3. So if I took 6 and broke it up such that there was 3 in each group, there would be 2 groups of 3, and that would be one way to think about division. But the other way to think about division would be this. I'm going to make 3 groups. How many would be in each group? So I make 1 group, I make 2 groups, I make 3 groups, and so notice I made 3 groups. If I made 3 groups, there would be 2 groups or 2 copies of 3, 2 in each group with 3 groups to make 6. So there are both ways. When it comes to integers, the how many copies of is going to be I think, the more productive way of thinking. How many copies of? And again, how many copies of? In this case, starting with a blank slate, I'm thinking about how many groups of 3, how many copies of 3. 1 copy of 3 put on the table, 2 copies of 3 put on the table. Since I'm putting them on the table, we call that a positive, and we get 2. Are you ready? Now I want you to pause the video and think. Using this phraseology, how many copies of, and would you have to put copies on the table or take them off the table? Putting on would be a positive, taking off is the opposite, so it would be the negative. How many copies of? So, how many copies of 3 does it take to make -6? Now, just to connect, this said, how many copies of 3 did it take to make 6? 2 copies of 3 made 6. This one says, how many copies of 3 does it take to make -6? Now, pause the video. Bust out your virtual manipulatives, play for a little bit, engage in the productive struggle. Come on back when you're ready. Are you ready? Lost my mouse. Mouse, where are you? So I'm going to start here with the virtual manipulatives, and I'm going to make an argument that when you saw how many copies of 3, so there's a copy of 3. How many copies of 3, there's another copy of 3. How many copies of 3 does it take to make -6? And as you see me making copies of 3, I could make copies of 3 all day long. And notice it was positive 3s, wasn't it? I hope you saw it. And it was -6 divided by positive 3. How many copies of positive 3 does it take to make -6? You can make copies of positive 3 all day long and you will never make -6. And so this is a struggle. This is a problem. An opportunity to solve a problem. There's got to be more to the story then. It can't just be how many copies of 3 does it take to make -6. We have to think something different. Now, what's the different thing? Do you remember back with multiplication? We could create positive copies, like 5 times 3 or 5 times -3, or we could do the opposite. We could flip. And when there was flipping, that meant we had a negative result. So I can make copies of 3 all day long, and I'm not going to get 6. Let me get rid of all my extra ones here. But if I do the opposite, if I made all of these red instead, that rhymes. I guess I can't just do that, can I? All right, so I'm going to get rid of all of these. I wish there was an easier way to flip these. Wouldn't that be cool? But if instead of making copies of 3, I make the opposite, I make copies of -3, notice it takes 2 groups opposite of 3, the negative of 3, to make -6. So I'm going to go back to my PowerPoint and show it to you a different way. Pretty challenging, isn't it? It's hard to think about this. I think this is why sometimes teachers resort to just telling. Kids just remember, and maybe a song or a rhyme or a poem to make it memorable. And all of that can be good, but if it's not connected to deep mathematical understandings, I'm going to argue that it's not all that good. It needs to be both. So how do we get both at the deep understanding, sense making, and then to have a mnemonic or a rhyme or a song to help students remember? That can be good because it's all then connected. So back to the challenge. This says, how many copies of 3 does it take to make -6? And I tried to convince you that you can make copies of 3 all day long and never make -6. So there must be more to the story. There's got to be the flipping idea. And so instead of saying how many copies of positive 3, I have to think about flipping. So I'm going to need 2, but -2, the opposite of 2, to make them red. Or let's do it this way with the sea of zeros. instead of creating positive, maybe we need to remove negative. It would look like this. What do you see? The sea of zeros. I start with nothing. And now, instead of thinking creating, I'm going to have to remove copies of 3. I'm going to have to remove negative copies of 3 in order to get negative 6. So in my brain, as I'm thinking about this, as I hope my students, my 6th graders will be thinking about this, they're going to be thinking like, well, I can't create copies of 3 to make negative 6 because that doesn't work, but I can remove. That's the opposite. Negative. I can remove copies of 3 and be left with negative 6. Watch. How many copies of 3 do I have to remove? 1, 2. Got some extra zeros. Did you see it? I removed a copy of 3. I removed a copy of 3. I had some extra zeros. And after removing the copies of 3, voila, I'm left with my negative 6. Now, removing is a negative. It's an opposite act. So the negative here is remove. How many copies of 3 did I remove? 2. So remove 2 copies of 3 from a sea of zeros will produce negative 6. That's how it goes. Now, you really just need to think about this, ponder it, consider it. Let your brain make sense of this. Go to the virtual manipulatives and play with it. Try to go back to multiplication. How did it work with multiplication? This is just the inverse, and now we have to think backwards about how to figure out negative 6 divided by 3. And then, try one more. What about happened? Oh yeah. My brain just went crazy there. Just did negative 6 divided by 3. Now we're going to do 6 divided by negative 3. I thought I'd already done that. Will you please pause the video and make your brain think through 6 divided by negative 3, since you've already seen it. How many copies of negative 3 does it take to make 6? Pause the video. Give it a shot. Come back and find out. Did you do it? First of all, how many copies of negative 3 give 6? You can copy negative 3, red chips, all day long, and you're never going to get to positive 6. So there's got to be more to the story. There's got to be a flipping, so negative. So right now, my students are already thinking, I can't create copies of negative 3 long enough to produce a positive 6. It's not going to happen. But I can flip them over. Oh, negative. Already they're thinking that the result's going to be negative. Or if instead of creating copies of negative 3 until you get 6, what if we removed copies of negative 3 until we got 6? So we start with our sea of zeros again. And then removing is an opposite act, so that I know my answer is going to be negative. I'm going to remove a group of negative 3. I'm going to remove a group of negative 3. I got some extra zeros there. But when I removed groups of negative 3, I got left with the positive 6. So the question is, how many groups of negative 3 must be removed to produce positive 6? So removing is a negative act, and I had to remove 2 groups of negative 3 in order to get 6. Let me show it to you again. Starting from a sea of zeros, I removed a group of negative 3. I removed a group of negative 3, had some extra zeros, and after that I had positive 6. So the way I think about this is, I removed 2 groups of negative 3, and I got 6. Or, pretend that was a positive there, you could say 2 groups of negative 3 is negative 6. I need to flip them. Flipping over 2 groups of negative 3 will give you positive 6. Let me say that one again. Let this one sink in. Flipping 2 groups of negative 3 will produce positive 6. Now, either way it works for you. Now, I want you to go back. You're going to have to cycle back to this whole thing, even back to just 6 divided by 3. How many groups of 3 did it take to make sense? Notice we brought them in. We created 2 groups of 3 to make 6. That's a positive act. We removed groups of positive 3 to be left with negative 6. We removed groups of negative 3 to be left with 6. Now put it all together and try this one. Pause the video. Give it a go. How are you thinking? Try it with the manipulatives. Come back and see. I hope you did it. Here it goes. The question is, how many copies of negative 3 does it take to make negative 6? That's what division says. When the question is, how many copies of, that's a division. That's the inverse of multiplication, which is division. How many copies of negative 3 does it take to make negative 6? 1, 2. Now, what did I do here? Did I take them off? Did I put them on? Did I flip them? Nope, I didn't flip. I put them on. It's a positive act. The action was positive. I just created 2 groups of negative 3 and I got negative 6. I put on the table 2 groups of negative 3 to get negative 6. It's a positive act. I didn't have to flip anything. Notice when I created 2 groups of negative 3, I got negative 6. Didn't have to flip anything. Notice I put them on the table. I created them on the table. That's a positive act. So it's a positive situation. Now, you might have to just take some time to think through this. Now, as you hear me talk about it, you just have to know I've been talking about this for decades. And so for me, it's so deep in my head that I've got it. You need to now think this through. Try it, play with it, talk to somebody about it, both multiplication and division, and see if you can get your brain to sort out what's happening here. Engage in the productive struggle.